Okay, so you have 12 minutes and then 3 minutes for questions. And we'll give you a warning.
Hi, my name is Buck. Usually people asking me if I'm German, if I compose music for a living. No, I'm not German. I don't compose music for a living, but I do compose code for the last 20 years or so. And one of my last projects is LMP, which I'm here to introduce you to it. Let me start by playing you a short video clip introducing LMP. Why video? I figured a picture worth 1,000 words and a video has to be at least 2,400 words, right? So I hope it goes. No words so far. Oh, there it is. Well, I hope you enjoyed that. So some background information. LMP started in 2007 as a system to support mission planning, hazard avoidance for constellation program, and also to disseminate information data, send data from LRO. Our plan is to leverage a lot of software that has already been developed and that really create a new challenge for us to assimilate all of these existing software from Arizona State University, from CREL, from USGS, and also some existing from our own Jet Propulsion Laboratory. Today we are online at www.lmp.nasa.gov. You can go here at any time. No login is required. We do have quite a few users. NASA, of course, uses the industry and education as well. And our recent latest user is actually the Hyperwall at NASA headquarters. If you ever come by the neighborhood, come and check us out. Here's some latest data that we have from LRO. This is a colorized digital elevation map. And this is the Balmer Basin slope, also from a derived set of data from LRO. This is the Rima Hadley in 3D. I'm not going to spend too much of time going through the list of products. I would encourage you to use the website and look at what we have there. And I also going to be demoing the portal in the next room, so I can show you there. Some of the data that we have are quite interesting. One of the things I like to talk about is the lighting model. This is a piece of software that we developed at JPL. With the portal, we allow you to go in and basically just draw a bounding box and ask it to calculate the amount of light, amount of wattage hitting that portion of the moon at a function of time. It's quite useful for planning rover site. Here's our capability summary. We have a suite of user interface with access authentication. As you can see in the video, it's quite extensive. However, if the takeaway point from it is we have so many interface because the software architecture actually supported. If you don't like what we already developed, you can actually use the entire, develop your own quite easily. For browsing, searching, and download, we use Apache index engine that allow you to search the data without any syntax. It basically gives you the ability to search like you Google something. We integrated completely with PDS, so when you search, your search also hit PDS as well. At any point on the surface of the moon, you can do data annotation by drawing a box or clicking on a point and attach your own data and share it that way. As I mentioned, everything is done as web services, so it provides for a very easy integration with other systems. And our system is also a collaboration framework. The tool I already mentioned, lighting, we also have slope and hazard, allowing you to calculate the slope so that you can figure out where to place your rover without tipping it over, and also hazard and drop detection. We have pixel value, allowing you to move the cursor anywhere on the moon and giving you the value of that data set at the point of the cursor. We support subsetting in real time. You can just get a subset of the data that you see anytime. Our plan is to, of course, increase the user base and also, most importantly, integrate it with new RRO data as it become available. I'm gonna just go straight into the architectural principle. This is our software is a multi-layer architecture. A lot of the time when we do these kind of analytic computation, it costs a lot of computing power. So we actually built a workflow engine and using cloud computing for handling these kind of computing spike. For example, if somebody asks to calculate slope for a large portion of the moon, that will take several hours. And we don't want to size our system up to handle such a, just a short use. So we use cloud computing for this. So again, on top is our user interfaces. The reason we can do this is because we have very loose coupling between our top level and the tier in between, and the layers are actually language independent, so it will support any kind of user. Security is provided because we are a multi-agency program. We have to allow anyone to get into the system. So if you are a NASA user, you can already log into the system today. Our middle tier called application tier allow basically make all of the differences in all of the tools that we have assimilate into the system disappear and giving you a very consistent service. And last but not least is our data tier, where you have the geo information server, you have workflow, you have catalog, metadata, everything that needed to present data. So I'm gonna be across the hall doing the demo. If you're interested, please do come by. And these are the contact information. Thank you.
We have time for one short question. Anybody have any questions? Yes.
What sort of resolution are the
Depending on the data set. It's very, I think the highest resolution we have is 1 meter per pixel.
Okay. Any others? Okay, let's thank our speaker again.